All right, ladies and gentlemen, so today we're beginning our next chapter, which is chapter 7, and it's on these things that are going to be called monomials and polynomials. There's a lot of rules for this, but the more we practice it, the better you're going to get at it. And this is honestly one of those things that you're going to use throughout the rest of the math classes that you take, and then they just keep expanding on it from there. So we're going to start our discussion today with these things called a monomial. And we did a little bit of this last year in accelerated 8th grade or 7th grade. So some of it might look a little bit familiar, but a lot of it's going to be brand new. But anyway, a monomial is either a number, and I'm using the number sign, a variable, or the product of a number and a variable. So there are not any addition or subtraction signs. Everything's going to be multiplied together when we're talking about monomials. A constant is a special kind of monomial. We've talked about constants before. Now we're just saying that they have another name, and it's a monomial that's a real number. So in other words, no variable. So if all you have is a number, it's also called a constant. The monomial is called a constant. So today we're going to look at 3 different types, and we have 3 different sets of rules. The first one is product of powers. And I'm going to kind of show you an example of this here. If I have b to the third times b to the fifth, and what I want to do is I want to be able to rewrite that and simplify it down into one thing. Well, b to the third, and please add this into your notes, really is telling me that I'm multiplying 3 b's together. B to the fifth means that I'm multiplying 5 of them together. Well, if I multiply all of those, that's supposed to be a times b. If I multiply all of those together, I'm multiplying 1, 2, 3, 4, 5, 6, 7, 8. So that can be written as b to the 8th. Well, to get from here to here, without having to show all this work, we add their exponents. This is a rule. This you must memorize. So if I'm multiplying and they have the same base, so multiplying, same base, you add their exponents. It's a rule. You need to know it. Sometimes you'll see what is called power of a power, and that's when we have one base, but we have 2 exponents. And in this case, if I write this out, b to the third to the 5th power really means that I'm going to have 5 b to the thirds being multiplied together. Well, we know from up here that now I would have to add. So if I add 3 plus 3 plus 3 plus 3 plus 3, I get 15. So b to the third to the 15th, again, if I kind of skip that part, we multiply the exponents. So again, this has to be memorized. So if I have one base and I have 2 exponents, we multiply those exponents together. Now, sometimes you might have more than one base inside, and you are then taking and having to share the exponent outside. So you find the power of each factor and then you multiply. It's a lot like distributing. So you'll see what we did here is we took this and we shared it out and we rewrote it. This really means that -2 to the 5th power, x to the 5th, and to get the 15, we had to multiply the 3 and the 5. Then we figured out what -2 to the 5th power is, and that's -32. When you put negative bases into the calculator, you have to put it in parentheses in your calculator. Because your calculator is smart enough to do order of operation. So if you didn't put this in, it would tell you to take 2 to the 5th and then make it negative. This is saying, no, my base is -2 and I want to do it to the 5th power. So when it tells you to simplify expressions, these are the things that you have to look for. Each variable base appears exactly once. So in other words, you've put all of those together. There are no powers of powers. You've multiplied those through, and any and all fractions are in simplest form. All right, so let's go through and see if we can do some of these examples. So simplify each expression. So that means that I have to go through those things. Fractions in lowest term, no powers of powers, bases are only listed once. So here I have n to the third times n to the seventh. So these are being multiplied together. So I'm going to add their exponents, n to the 10th. When I have this one, if I have constants out front or coefficients out front, I have to multiply those together. So I'm going to do 3 times 7. I'm going to actually write this out so you can see what I'm doing. I'm going to do 3 times 7, and then I'm going to do y to the 4th times y to the 5th. Now, you don't have to show this. I'm just trying to show you where it's coming from. So 3 times 7 is 21. And my rules from before, when I'm multiplying, I add my exponents, y to the 9th. All right, so let's see down here. So I have a 3. I don't have any other. If you don't see a coefficient, it's still always 1. So I'm going to write this out. I'm going to have 3 times 1. Let's put our p's together. P times p to the 3rd, and t to the 3rd times t to the 4th. So if it helps you to rewrite it using the commutative property so that these are grouped together, go right ahead and do that. So 3 times 1 is 3. P times p to the 3rd. This has an exponent of 1. If you don't see the exponent, it's a 1. Just like if you don't see the coefficient, it's a 1. So that's p to the 4th. And then t to the 3rd times t to the 4th is t to the 7th. So when I look at this, right, I have all the bases are only listed once. I don't have any powers of power, and there weren't any fractions. So we're good. All right, number 4. So I'm going to rewrite this. -4 times -6. I'm going to put those together. Then I have r times r to the 5th. I have x squared times x squared, and t to the 3rd times t. So now I can go through and do part by part. If you don't have to do that, and you can just kind of match them up. But -4 times -6 is 24. R times r to the 5th, there's a little 1 there as an exponent, so that's r to the 6th. X squared times x squared is x to the 4th. T to the 3rd times t, again, I'll fill in that 1, so that's t to the 4th. So that kind of gives you some examples. Again, if you don't have to rewrite them and you can just kind of do that in your head, great. If you're getting yourself confused, I want you rewriting it so that you're using the commutative property to group those together. All right, next set of examples. So now I have powers to powers. I see one base, and I see these 3 big exponents. So it doesn't matter if there's 2, 3, 4, 5, 6 exponents. If you have one base, you multiply those all together. So that's going to be 2 to the, let's see, 3 times 2 is 6, 6 times 4 is 24. And you don't have to, because it said simplify and not evaluate, I don't have to take that down since that's my only base. You don't have to figure out what 2 to the 24th is. For number 6, again, I'm going to multiply those together, so my base is 3. So I have 2 times 2 is 4, times 3 is 12. All right, here's one now where I'm going to have to share that. So I'm going to take and basically do my distributive property with my exponent. So I'm going to have -2 to the 5th. I'm going to have x to the 5th and y to the 3rd to the 5th. So I kind of took it and broke it down. I put a 5 with each of those. Now I'm going to go through and do the math. -2 to the 5th is -32. I did it in my calculator. X to the 5th, there's nothing to simplify there. And y to the 3rd to the 5th, this is where I multiply. Y to the 15th. So a lot of this is going to be about being able to recognize what they're asking you to do. And the more we do, the better you'll get at that. So in number 8, I have another, I'm going to distribute my 3 exponent. So I'm going to have 5 to the 3rd, x to the 3rd, y to the 3rd, z to the 3rd. Well, the only thing here now that I can simplify is 5 to the 3rd, which is 125, x to the 3rd, y to the 3rd, z to the 3rd. All right, let's try a couple of harder ones now. So now I have a whole lot of parentheses going on, and when we have a bunch of brackets and parentheses, we're really kind of working our way from the inside out. So this part right here, I'm just going to rewrite. -1/4 x squared y to the 5th to the 3rd. So I have to start inside here. So I have to distribute my 7 exponents. So that's 2 to the 7th, times x to the 7th, y to the 7th. So I got rid of those. Now I have to get rid of this one. So I'm going to take my 3, and I apologize that my handwriting is so bad, and I'm going to distribute my exponent of 3. So this is 1/4. I'm going to multiply these together here. So I'm going to get x squared to the 3rd is x to the 6th. I multiplied those. Y to the 5th to the 3rd is y to the 15th. Times 2 to the 7th, x to the 7th, y to the 7th. Okay, well, now I have to actually figure out what 2 to the 7th is, and I'm going to use my commutative property to help me regroup these. So I'm going to have 1/4. 2 to the 7th, when I put it into my calculator, is actually 128. And then I'm going to group my x to the 6th, x to the 7th, y to the 15th, y to the 7th. So I use my commutative property in order to do that. Now I'm going to put those together. So 1/4 of 128 is 32. I'm going to actually write this up here because I ran out of room. X to the 6th times x to the 7th. Those are being now multiplied. We add the exponents. And then y to the 15th, y to the 7th. Those are being multiplied, so we add to the 22nd. So that whole big thing reduced down to 32, x to the 13th, y to the 22nd. All right, number 10. So in number 10, again, I'm going to start with this one and work my way out. I'm going to multiply those two things together first. So I have 3xy to the 4th times negative 2y. 2 times 3 is 6. So I'm going to multiply those first. Now I can do my distributive property because I have to share this out. So I have 3xy to the 4th. Now I'm going to have negative 2 to the 6th and y to the 6th. Right, so first I simplified those exponents by multiplying them. Then I had to share it out because it was on the outside of the parentheses and it has to go to everything on the inside. Now I'm going to rearrange and kind of group this together. So I'm going to have put my coefficients first, 3 times negative 2 to the 6th. I don't have any other x's, and then I have y to the 4th, y to the 6th, and those are all multiplied, so I'll put dots. Negative 2 to the 6th was 64, so I have 3 times 64 times x, and I'm going to add those, y to the 10th, and then I just have to figure out what 3 times 64 is. I did that on my calculator. 192x, y to the 10th. I know they're hard, I'm not going to lie. All right, so I want you guys to try number 11 on your own, and we'll go over that one in class. But I want to get into the word problem. So it says express the area of a circle. So we're talking about area of a circle with a radius of 2x, y to the 3rd as a monomial. Well, I know to find the area of a circle, it's pi r squared. So we're reviewing some geometry from last year as well. They're telling me this is r. Radius of, there's your r. So pi, and then I need 2x, y to the 3rd squared. All I did was take out r, and I put in what they told me, 2x, y to the 3rd. This is now where I have to distribute my 2. So I'm going to have pi, 2 squared, x squared, and then y to the 6th, because I have to multiply those together. So now I just have to figure out what 2 squared is, which is 4. So we write this 4 pi x squared y to the 6th. I don't multiply by pi. We keep that in there because it's a real, excuse me, it's an irrational number. So I don't want to put that in as 3.14. We keep the pi. Express the area of a square with side lengths of. Well, I know the area of a square is s squared. They're telling me this right here is your s. So I'm going to take s out and I'm going to put that in. So I'm going to have 3xy squared. That whole thing gets squared. Okay, well this is now one where I have to distribute and share. So I'm going to have 3 squared, x squared. These get multiplied, y to the 4th. I can simplify 3 squared, that's 9, x squared, y to the 4th. And the last one here